So our next speaker is Nitzan Gutman. He's going to be talking to us about optimizing OpenSIPS cluster management using distributed backend systems based on RabbitMQ, Elasticsearch, and RabbitMQ based on Elastic. No, I'm sorry.
No.
And more.
Great. Thank you very much, Alex.
All right.
So first of all, it's very exciting and.
Cannot hear.
One. Can you hear me? Now you can hear me.
No.
No. One. Oh, now you can hear me?
Yes.
Yes?
Yep.
I'll just talk out loud, no worries. So it's very exciting to be here again. The OpenSIPS Summit is always an exciting place to meet other geeky guys that understand our language and joke, and it's really exciting to be here again and be part of this community. The long headlines that you were I will try to make it a funnier, better presentation than another boring microservice kind of look at how I build it kind of presentation. We will talk a little bit about who we are, the evolution of topologies, kind of how to think of creating the best topology, and a little bit about the challenges when working with the microservice environments. So first of all, Voicenter, myself, me and my ugly twin brother, Shlomi, started the Voicenter in Israel a little bit more than 10 years ago. We're a licensed ISP, a little bit more than 100 employees. We develop a lot of real-time communication platforms, very concentrated on focused on contact centers and cloud contact center solutions. We also work with my dearest colleague, Alex. Yeah, the MC, Alex. I'm sorry, I didn't mean to not use your title. Together in operation in the States, and together with Giovanni from Open Telecom, providing a voice switch solution for telco operators and organization, and it's a very pleasure to be here with them. About myself, I got released from the Engineer Combat Unit about 15 years ago from the IDF, and joined my twin brother into starting this operation. We've been developing projects for organizations, governments, and entities worldwide for the last 15 years, very focused on Open Telecom, on open source telephony, and generally on open source. Really big contributors, and I'm very enthusiastic to support open source projects wherever they are. So a little bit about microservices. We'll not do that again, relax. Okay, I'm sure you heard a few of those. But we are talking about the major problem of transferring from a system that is very monolithic, very one point of failure, one gear, one equipment that you just put in some kind of a data center and you pray it will work. And I guess about a decade and back, it used to be like that. Then you were able to do a monolithic system, and that will be like a general understanding that that's the way things work. Maybe as a CEO, it's very good to see that you bring me a box that does that stuff. Just give me one box. Don't get me too complicated. One system that does it all. But the more the years further we go down the years, and we need more advanced stuff, this monolithic dream becomes a nightmare because it's really hard to fulfill the high availability and the flexibility needed when you're blocked into one equipment, one vendor, or one system without the ability to continuously develop your system. And I'm sure that the crowd in this room totally understands the importance of continuously developing, and I guess this is part of why you're here, other than the great Amsterdam atmosphere. And this is really one of the biggest reasons to move from monolithics to others. And the humanity has tried to solve it by trying to move to a layer-based solution. I just got an idea for a good example about why layers not necessarily work. You know that we have a dual redundant elevator in the building. But then again, we're all stuck here on the 5th floor, cannot go down without elevators, even though there were 2. And now we have, I guess something left over from the DevOps environment, the service elevator, that for emergency stuff, we can move the packets over there, but there's no real guarantee that it will really continuously working, even if you have 2 in high availability. So you can guys fix the elevator now. I got the point now. Thank you guys. Thank you for the help. And when we move from layers to microservices, obviously, and then again, it's even more obvious in microservice, the less single points, the better. But then again, it's more complicated to maintain, to monitor, and that's exactly the challenges we'll progress and talk about. And where is Mike of Rudis? Is he here in the room? Yeah, you saw that? I got you a cat and dogs in the presentation. Good.
I'm so excited.
So, this is like a general microservice topology, okay? Everything is like this. It's very simple to explain. And this is part of the challenges, obviously. If we try to, I see people actually focusing on that. That's no point of remembering this structure, guys. Go on.
You want me to explain that?
Yeah, you want to go over that as the CTO? No?
You're working against you.
Yeah, exactly. Yes, hard questions again, I know. So, when we talk about finding the perfect topology, if you take 2 engineers without any previous knowledge and ask them what's the best topology, they will already have an opinion, for sure. But the point is, when you try to plan and think of the right topology, you first need to analyze what are the requirements, because there's so many ways to deploy the same stuff in multiple or single data centers or topologies with multi failovers. And I have like this bad experience once that we had a round-robin container that was also load balanced with an Nginx and also had the DNS failover. And by the time something got wrong, it was impossible to find it. So overcomplicating high availability can also be a disadvantage, and you need to really think about the requirements, not as to let's do everything the best you can, but really think about the requirements before you just shove in more and more configurations and stuff into your system. The requirements are really a very long list. We try to narrow it down to what's really about microservices, that is the requirements that are different from other places. And we found that, first of all, geographic location, which is something that is more and more out there now, that people need dual data center or more than 2 data centers availability. And we're all on it with the OpenSIPS 2.4 Anycast support and clustering support. And this is a very important requirement that needs to be answered. We, of course, have the capacity. How many calls or sessions this system needs to hold. Obviously, there's no point investing in high volumes when you need low volumes, but with more flexibility. Existing technology used. If you need to use iSoup to integrate into a SS7 telco operator, or if you're stuck with an old Genband in the network, or Nortel, or whatever you need to, God forbid, Nortel, to integrate, then it's really something you need to think of in advance, because there are very specific limits into what these technologies and existing gear is supporting. And generally, interoperability, you go, and usually no telco operator or a big organization is coming and purchasing his telephony system or whatever microservice system from scratch. It's always integrating into something that already exists, and you need to make sure it's interoperable with other stuff. And something that people sometimes forget, of course, is the budget. Because you can always overkill a project or a system with many demands and many requirements, but then you will not meet the budget needs, and that's, of course, part of the requirements. It's not always just let's make it right. So what is the perfect topology? Obviously, there's no perfect topology. It really depends on the situation and on the case and on the requirements the situation has. But the different reasons that these requirements are always changing is the geographic locations that are distributed with our new systems, the functionalities that needs to be provisioned, and the multi-tenancy that each one of those devices, servers, hardware, gears is serving multiple clients and not just a single client or just a single thread or a single task. So that makes it more complicated to manage and review and monitor, etc. So the challenges I wanted to mention and show a little bit about the tools that we used in order to overcome are the observation. Okay, all the DevOps, the creation, the continuously installation of servers, the monitoring of the systems, the integration of the systems to other platforms, and of course all the logging, which I'll discuss later with what we're doing with the RabbitMQ and the Elasticsearch. So about the observation challenges. We obviously have several of them: the network, the functionality, and scaling the resources as we go up and down as much as we need. About the network, so obviously the new solution we mentioned many times here last year and this year is the Anycast and the OpenSIPS clustering support. And this is something that I will respectfully, I even put your picture on, man. Okay, do you see it? You see it?
Yeah, I see it.
Very good. Tomorrow, that exact time, 3:30 after the...
It doesn't make me feel very special.
No? Ah, because I didn't put your picture on it? Now you're jealous?
If I looked more like a cat, everything would be just fine.
So definitely come to Alex speak tomorrow and hear all about it. But just in general, I'm not taking all the fun out of it, relax. But just in general, two main reasons to use the Anycast. First, of course, is the high availability and dual data center, high availability, that even a data center goes down, the calls continue flawlessly and the end user do not feel it, not just a server, a whole data center. And the second one is more about the localization of the servers, getting them as close as possible to the end user to avoid any latency issues, and of course other packet loss and network issues that obviously, as long as the further you go, the more guaranteed you are to at some point to meet some network issues. So about the provisioning challenge. This is something that I believe you will find interesting, that part of the need to provision parts of the system in a dynamic and in the right way is an example we did with the provisioning OpenSIPS to tell the free switch into which URL to address when he's doing his URL requests. So we have actually, we used it in our case study to have the distributed queues solution. So once we have a call center queue with the agents from around the globe, what they call follow the sun feature, that wherever you are, guys will be there and be available. What we have is we use the OpenSIP that is actually managing the state of all the agents, the calls and everything, in order to identify the incoming call that is coming for that queue on which agent it should land, redirect. And if the agent is in the US, then the free switch already knows to communicate using the CURL model in front of the US data center and information system. And obviously, just the same way, if the call was meant to a European agent, the call would have went to a European data center. And this is very helpful with managing the network. It reduces latency issues and international networking issues that obviously are less stable than intercontinental networking. And this has been a huge step for us in making stuff more simple and operable and stable. And of course, you can find that on our free switch repository for download if you want to use it. One other thing that is really nice, that I think that is nice to mention, that we managed to overcome the barrier that at a certain point our servers were scaling up and the users were using more and more channels, and we noticed that we need more servers in our system. And we found working with the Linux containers and Proxmox to be very reliable and very flexible to our demands. We actually see when file decryptors or hard drives or CPUs or load averagers or whatever sensors you have are reaching certain limits, and that tells our system to just put up more containers to consume and to operate and to perform the needed job in a way that is really bringing the cloud computing into the internal network and allow us to offload resources as much as we need and to stay flexible with demands and peaks. So this is really a nice tool that we were using for that. About the monitoring challenges. So of course we have many services, many different services that we need to monitor, and there are many, operation systems, equipment, data center services, ports, so many things that you can monitor and think about. And this is like the enormous amount. As more as you grow and add more features, the more that this becomes a really hard challenge. The geographic distribution, it demands network connectivity between each one of the microservices. And what we have sometimes after that is the chicken and the egg problem. For example, we log into a server and we see that the hard drive is filled because of a log file rotation that we didn't even know that exists, that start filling up with no log rotation, and it only happened, and we don't know if it's the chicken or the egg, or is there a bug that caused this log rotation to fill up, jamming the hard drive, causing the server to crash? Or is it just log rotation, the hard drive filled, and then the server crashed? So you really need to have the logs indexed and filtered in the right way so you can extract them and get business intelligence out of them in a sec, and not start digging into jigs of CSV files in order to try and find your answer. And one more thing that we added, so I'll get to that in a second. So basically, the basic monitoring is something I'm sure everyone are doing. I'll be responsible not to. And basic ICMP pinging, SNMP trapping, and monitoring, and of course HTTP monitoring to make sure everything is up. That's nice and that's good and that's very important. But in a microservice environment, you can encounter a situation when the service is just answering 200 OK no matter what is being asked, for example, or other stuff that can get wrong, and you really need to check its functionality and not just that it's up. And so we use functionality testing, simple API testings. We check the response time, the latency and stuff, and the valid response. But we also developed end-to-end solutions for using the open source common market tools available, and we use CPP for testing, for checking concurrent calls capacities and other performance under high volumes. We're using Verisip. Actually, that's a nice example. We're using Verisip automated call testings. We actually have DIDs around the world and an automated dialer dialing those DIDs, playing them a record, which is recorded from both sides, and then we analyze the audio from both sides of the call, match it to RTCP statistics, and understand if we have a problem or not. You see, okay, we can see if there's caller ID issues, if there's latency issues, if the problem only exists in specific providers or specific locations worldwide. And one of the extra tips that if you're going that way, just make sure you watch your international calling bill. We got this system, spending hundreds of dollars before we thought of a simple, stupid algorithm that examines how many calls we have to each one of those destinations and calculates the ratio of testing those destinations by the amount of calls to make sure you test once an hour a destination where you have millions of calls, but only test it once a day if you only have a few dozens of thousands of code per day. So this is one nice example for a testing platform. And the Puppeteer. The Puppeteer is a great tool. It's usually used for UI testing and automation when you build like a web interface, and we're using it really. We try to push as much as we can A to Z processes into the steps this Puppeteer is performing, so it doesn't only go to a website and see that it's up. It's actually logging in, it's creating a new user, it's creating a new SIP session, it's trying to make a call using that new user that was just created, etc., etc. And all those flows are continuously developing in our internal systems to make sure that more and more monitoring is being performed. So if something is a bit slower or not behaving the expected way just before we launch a beta version, we know it in advance. And that's a nice part that we added a few years ago. Shlomi wrote it, I believe. No, Razvan.
Rewrote mine. Ugly code.
We were lucky enough for Razvan to rewrite Shlomi's code, so it's actually working. And we have the latency update model that actually allows us to know every time the end user is sending a keep alive message, not only his latency and the user location, of course, that he has, the NAT and all the parameters behind it. We also gather other real-time statistics on him. For example, what's the current calls that he's having right now, or which queues he belongs to, and other real-time events that are all related into that entity in mind, that is the extension sending the latency packets. And we, of course, send it all into a RabbitMQ queue that then goes through some logic before it goes into an Elasticsearch indexed and ready for us to pull and know the information when we need it. All right, so the integration challenges, it's a whole world of itself. As I mentioned before, when you come with a microservice platform, it's usually into an existing platform, or you have other platforms that you need to integrate. If it's an existing billing system or a CRM or ERP or you name it, there's a tremendous amount of systems out there that potentially need to be connected into, integrated with. And there's, of course, all those multi-versioning of all those different devices and systems, and always changing needs. You know, by the time you end selling and implementing a solution for one of the customers, half a year later, the manager replaced, and suddenly a whole new set of features come into the exact same company, same doing, same actions, and changes suddenly, the needs suddenly change. So it's something that is commonly happening, and you need to remain with the flexibility to continuously develop and integrate. And this is why we are using, I want to mention two different tools that we're using. The Jenkins server in order to do the DevOps implementation, and you know, every night after the developer ends up developing his feature branch, he already has it implemented automatically every few minutes on a live server in a data center, which he can actually do live testings on. And of course, other methods that we're using for. And that's a nice little project that we just published on GitHub a few months ago. We call it My Swagger Hub. It's actually a MySQL scheme that is used to create Swagger file, JSON file or YAML file. And anybody here knows Swagger? Really? Okay, so I will do the few sentences that's saying that Swagger is just like a markup language that helps developer define the right methods and parameters in each one of the parts of his system in a centralized way, which really helps developing systems in progress, because every time we think of a new feature that demands a new field to be added to some kind of an object somewhere out there, instead of thinking about the 3 months roadmap it will take to find all these locations and track them down, make the changes, make the test script, make the entire global system test after before you launch. You just have this tool that you add to the Swagger, and the Swagger already generates the backend files, the SQL, the MySQL functions, and many other tools that makes it really fast for us since we start using this solution to progress and add more and more features in a much faster, organized, and documented way, which is really important as far as you grow and more people and hands and chefs are getting into this nice dish. Who sees an old lady? Who sees a young lady? You know that? Okay. You don't see the face? That's a different problem, man. You should definitely see a shrink then. Okay. My point here is that when you're looking at data, when you're looking at stuff, let's just take, for example, the simplest user table that I'm sure everyone has in their system somewhere. Just the user table with the user ID, username, and user status, and I guess a few more parameters, right? When we look at it internally from our internal systems, we would like to perform specific methods in specific volumes with specific permissions that we just, for example, the simple method of adding a new user, which is something that obviously we need to allow internally for our UI systems and APIs to allow. But then again, if an external user wants to use one of our APIs to add a new user, he's more than welcome, but obviously it's going to be on different servers, different platforms, different load balancing, different networking and security, different DDoS mechanism, different WAF, different, all those different stuff that comes around, and it eventually is the same add new user method. It's the same object, same answers, but it has to be, that's one of the suggestions that we found to be very important and adding a lot more reliability both to our internal and to our external APIs is the fact that we split them out into two different arrays of two different systems. So definitely security, robustness, and scalability are there. Using the right integration technology where we should. You obviously have different communications protocols from the UDP, from synchronic to asynchronous communication basically. And other than the UDP and the HTTP, we, as I mentioned, started using RabbitMQ and the AMQP protocol for message queuing, and that really helped us get our system much more robust, much more flexible, much more intensive, as we could just add another queue to the Rabbit and solve it this way in a way that will sometimes was not possible in a simple way like that. So. Login challenges. After talking about all those great microservice challenges, the biggest one and the last one I want to touch is logging everything. Usually the problem is that logs are scattered on multiple files in multiple servers, in multiple data centers, in maybe multiple universes in one day. But the point is it's really hard to unify all the information from those logs and get a fast answer as to what went wrong with this call or what went wrong in this server for that time frame. So it's really difficult to cross-reference those logs and to see what happened on the computer operating the soft phone while the server was getting the error messages. Whose fault is it? Where is it? Without seeing the entire global pictures, it's really hard to find out what happened. You need to have the right logging filtering because all this big data is enormous and you need to find a way to index it and map it in advance so you can really pull it out and use it rightly. And of course, security and regulations. I also had this Pulp Fiction picture with the, if you say GDPR one more time, So I didn't want to use the same picture, but I'm sure we all heard at some point on the GDPR curse. So I'll talk a little bit about that as well. So the login challenges. Obviously, as I mentioned, we have OpenSIPS, FreeSwitch, Asterisk, CGRay, Linfone, MicroSIP, provisioning systems, Node.js, backend and front-end, recording programs, Nginx or Apache and other, load balancers and UI, and every action the user is doing in the interface. All the billing actions, the logs of the billing action, not the billing in themselves, but their logs. All the access lists granted and disgranted. Of course, all the RTCP statistics and many other logs and active actions events that are occurring in the system. And what we're doing is just, as you see, pushing everything to the rabbit, making sure each one has his own queue, so you can pull it out and address it in the right way, in the right priority. And sometimes, just for example, when we use the RTCP statistics, the RTCP packets, which I assume most of you know, but I'm just making sure, it has all the latency, the packet loss, and all the network performance statistics inside those packets of every SIP call, of every RTCP stream. So those RTCP streams are actually sets of a few seconds of UDP termination, SDP, like the SDP has declared termination of UDP packets, and you do not usually have it correlated with, for example, the country this stream is eventually destinated. Okay, because the destination is part of the call of the CDR, it's not part of the stream. So you need to, for that example, take all those RTCP statistics, put them on a Redis on the side, and as soon as you know the CDR and the full duration and the destination and the billing and all the other stuff, you can collect it all together and have one object that has everything inside it, put it back in a different queue now, because that's like a more sophisticated log object, and only then push it into an Elasticsearch, already indexed it by the account ID or by the server source IP or you name it, whatever you want, to easily extract it with everything together, not trying to assemble different kind of logs from different systems with different timestamps just to try and find out again what happened. Other than logging, of course, without logging, someone looking at those logs and actively doing something about it, it's pointless. And what we used is I did left the SMS and email here, but I must say that we are really satisfied with the Telegram application integrations that we've made. We actually made different groups of chats to different escalation groups in our company for different decision makers and different responsibilities, including customers that wanted to be part of this group. We just created a new group for the customers, so they are also exposed to the alerts and the notifications that are concerned to their gear and equipment in the system. So after other than alerting and sending notifications, important notifications about it, it's really important, and I just mentioned it in a sentence before, about the indexing and mapping of the information into the Elasticsearch or any big data. It's really important, and if anyone here has already dealt with Elasticsearch, I assume he already encountered that mismapping or misindexing stuff can really get things slower as more and more data gathered into the system. And if you want to index an IP variable, so index it as IP, so the system will be easier to search by and to search for IP ranges and other functions that are not good for text indexing or integer or float calculation. So that's just one example out of many that if you do want to index stuff by IP range, you really need to have this IP in a IP type, data type, so it will be easier to aggregate the data that you want in any way you want it. Of course, one of the powerful tools for monitoring and alerting is the active and passive actions that our system is taking. We configure different thresholds for different monitoring levels and logs. For example, if a certain extension exceeds the amount of calls per second, or the amount of money spent in the last hour, 5, 10, day, week, or if the total count is exceeding, or if he's talking to abnormal destinations he haven't spoken before, and so on and on and on, and all those algorithms that are there to identify any fraud or suspicious traffic. But then again, if we would have blocked any suspicious traffic on our systems, we wouldn't have any customers, right?
Yeah.
You know, you need to be very gentle about it, and this is why we have certain different threshold levels. Okay, the first one only alerts our knock and some of those Telegram escalation groups I mentioned before. But if it reaches a certain point that is already, I don't know, for example, a single agent already passed the $100 a daily revenue. That's obviously abnormal in a way that no matter what time of the day you want that user stop making calls. And this is where you actually take the active parts, you take the logging and all the alerting and make it active by disabling the user, opening a ticket, sending him an email about it to avoid his frustration of the downtime and explaining what happened, and on and on. Also a different example for that is changing a faulty route. As soon as we see the RTCP statistics and MOS is degrading, and we understand that there's some issues with this provider, SIP provider, with this route, we don't need to wait for customers to complain and then change the route. We can dynamically do it automatically and just alert us that this has happened, so we can further go into it and see and open the tickets and look further into it. So this is some pictures from our dashboard, and this is actually part of the RTCP statistics dashboarding. As you can see here, this is just one example of the views that actually combines the ASR with the average call duration, with the average MOS, with the packet loss and the total calls. And these statistics are not really all together usually, and they need to be indexed together in order to show, for example, the MOS average of almost 5 in all calls, and you see the worst MOS in the blue drops in specific calls, and you can of course further analyze that, go into that, and see further information. This is an example of our heat map. This is obviously a good example for seeing one of the servers here with lots of reds on the packet loss view. You can see that this specific source IP server is suffering from some kind of packet loss. At the same time, other servers in that same data center and other data centers have not suffered from that. And you can narrow down, and this is just a nice example that just pops out a suspicious server to be wrong. It might not be the server wrong. It's maybe lots of users with bad connections are connected to it, right? But it definitely lights out and emphasizes if a potential problem might arise somewhere just before the customers complain about it. And this is another nice view of our system. Again, when you index the RTCP statistics together with the country, you can finally see each country and the average MOS, the ACD, the total minutes, the total calls by country, by ordering, by filtering, but whatever you want to do. And this is a nice example for a view that you can see on the left side the filtering that's possible to do. And then if you see that some statistics are awkward and you want to further investigate, you can filter more and more parameters and narrow down the problem into the specific issue, because sometimes troubleshooting voice issues, it's this top to bottom, bottom to up, top to bottom. Okay, this customer is suffering. Any other customers have it? Oh, the other customers are having it. Wait, they are in the same data center or not? Wait, they are in the same data center or not? Okay, and this trying to narrow down the system we try to design a system that will just allow us to click our thoughts this way and narrow down and find the exact timeline of where it started and what's the real source of the problem without opening a Wireshark, I promise. Okay. So after we log all this stuff together and we put it in Elasticsearch, as I mentioned, we need to make sure that it's secured, and we need to make sure it's departmentalized, which means that not every customer can view other customers' logs, right? Each customer's logs are part of the GDPR protection laws data, that the logs are also part of the sensitive data. They have the phone numbers, might have user IDs and other stuff. And you really need to remember that when you're managing logs. Before the GDPR, we manage log rotation by the size of the hard drive, right? I mean, there's no point deleting logs, right? Anyone here deleted logs not automatically, just for the fun? Making sure. Okay, I'm not the only one. Good. So we actually, I swear, we actually delete logs. Yeah, I admit. It's like a support group. And yeah. And part of
First
it.
of 12 steps. You know,
Yeah.
admitting the problem.
Deleting logs, exactly. So, guys, I delete logs. And part of the need to departmentalize the information in the logs and to make sure they're only accessible to whoever indeed has the permissions to do so, and only for the time is permitted to do so, and on and on and on, all those. We are using a very nice, great solution that I highly recommend, the read-only REST, which is a solution that allows you to use the Elasticsearch edition, but it also allows you, in case you're using Kibana, to departmentalize the indexes of the Elasticsearch and to allow different users logging into the Kibana to only be allowed to expose to the indexes that, for example, contain their account ID in the pattern, or any other tools that you can go very flexible with that make sure that even if you want to give your customers the benefit of enjoying the Kibana and all these wonderful tools, you don't need to compromise the security of the data and the logs of other of your customers. So the read-only REST is really a great tool for us, and we're using it, of course, with the JWT, and you can just shove into the JWT payload anything you want, and then use it later on when searching and indexing on the Elastic. And yeah, this is me putting it black on the white that I actually delete logs, I swear. And when you do need to delete those logs, usually you do it by age. But I swear I had more than 20 different conversations only in the last year with different legal advisories from different departments of big law firms, and each one of them has a different specification as to how we should delete the logs in order to comply with the GDPR. So we had people telling us delete all the call logs of calls more than 60 seconds, or delete all the calls of a specific data center, or of a specific DID number, etc. So you do not only delete the logs by the size of the hard drive, as I said before, you need to classify it, and if it's a more sensitive information, you need to delete it earlier. And if it's not that critical, and then you rather leave it for more than a month or two, maybe a year or two. And by the content and the business rules, and again, as I said, per the client's sick legal advisor needs.
You might get sued for that.
Yeah. I'm not dealing with any legal advisories. Thank you very much for your time. I hope it wasn't too boring. And enjoy Amsterdam.
Thank you, Nitzan.